Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about one complex DC circuit problem from Cambridge AS Physics. For this question, it is given to us that ammeter reading is 0. It simply means that there is no current passing through this ammeter. So this is what is given to us. And question is simply asking us, we need to find out the resistance of resistor R. So our resistor R is connected at this point. Now, as it is given to us that there is no current passing through this ammeter, it also simply means that potential at these 2 points is the same. Simply, if we connect our voltmeter between these 2 points, the reading on this voltmeter, that will be equal to 0. Now let's label some points before we answer this question. Let's say this point is P and this point is Q, and let's say this point is R and this point is S, and this point is T and this point is, let's say this is U. First of all, let's try to find out direction of current. I will simply draw one possible direction of current and then I will ask you one simple question about that. Let's say current flow like this. Now, my question for you is that, is it possible that current flow like this? Take some time and try to answer this question. Is it possible or not? Especially you need to look at current in this wire. Okay, let me explain to you now. If you look at this wire, you can simply see that current is flowing in two directions. Means current is flowing to the left and current is also flowing to the right at the same time in the same wire. It means current has two different directions. So is it possible? I hope simply you will say that not possible. So it simply means there is no current passing through this wire. As there is no current passing through this wire and also there is no current passing through this ammeter, so it simply means that these are two different circuits, or I can simply say that in this circuit current will flow like this. Current will flow like this, as you can see. So this is one circuit. We can treat this one as one separate circuit, and in this circuit current will flow like this. Current will flow like this. So this is another circuit. So we have two different circuits now. So here is one circuit and here is another circuit. Now, what is common between these two circuits? If we look at point P and if we look at point Q, this is our point Q and this is our point P. Potential at these 2 points is the same. We can simply write down Vp, this is equal to Vq, and these 2 points, they are at zero potential. We can simply say is equal to 0 volt. Now, potential at point R is also equal to potential at point S. We can simply say VR is equal to Vs. Now, the next thing, the question is that how we can find out potential at point R. In order to find potential at point R, we can also simply write down that the potential at point R is equal to potential difference across this 100 ohm resistor. Across this 100 ohm resistor. Let me clean first of all. It simply means that potential at point R, this is equal to potential difference across 100 ohm resistor. It simply means that if we connect our voltmeter between these 2 points, meaning between P and R, the reading on this voltmeter will be equal to the potential at point R. Why this will be equal to potential at R? Because point P, this is at zero potential. So we can simply say potential at point R, that will be equal to potential difference across 100 ohm resistor. So we can simply say that that is equal to potential difference across 100 ohm resistor. So R is equal to 100 ohms. Now the question is that how we can find out the potential difference across 100 ohm resistor. So we can simply say this is our 100 ohm resistor. Now we need to find the potential difference across this one. As you can see in this circuit, we have only two resistors, and these two resistors, they are connected in series. So we can simply find out the potential difference across 100 ohm resistor by just dividing resistance of 100 ohm resistor by the total resistance of the circuit, mean this circuit. So the total resistance of this circuit in this case, that is equal to 50 plus 100. 50 plus 100, and we need to multiply by EMF of power supply, that is 12. So in this case, the potential difference across 100 ohm resistor, that simply will be equal to 8 volts, and this is the same as potential at point R. As the potential at this point R we have already found, means the potential at point R, that is equal to 8 volts. It also tells us that the potential at point S, that is also equal to 8 volts. As we know, the potential at point S now and the potential at point Q, that is equal to 0 volt. It simply means that if we connect our voltmeter across this 200 ohm resistor, the reading on this one, that will be equal to 8 volts. Now as you can see, the EMF of power supply, this is equal to 24 volts, and the potential difference across 200 ohm resistor, that is equal to 8 volts. So simply we can also say that if we connect our voltmeter between point T and point S, reading on this voltmeter, that will be equal to 16 volts. Now as you can see here, resistor R and 200 ohm resistor, they are connected in series. It means same current is passing through R and same current is passing through 200 ohm resistor, but the potential difference across R is double than potential difference across 200 ohm resistor. From here simply we can conclude that R is 2 times of 200. So it means the resistance of R is equal to 400 ohms. Or we can also simply find out in a different way. As you can see, current passing through 200 ohm, let's say this is I1, we can say this is I1, and let's say current passing through this one, that is I2, but in this case I1 is equal to I2. So simply we can say the potential difference across 200 ohm resistor means the V1 divided by its resistance, that has to be equal to the potential difference across resistor R divided by the resistance of R. Let's say that resistance is R2. R simply we can write down R is equal to 200. So V is 16. So we have to find value of R. So this is just simply you will find out that R is equal to 400 ohms, and that is over R. So our answer for this question is 400.